Hey you guys, this is Chapter 1, Section 5, and we are going to talk about solving inequalities. So we have a few objectives here. We want to be able to write inequalities from a sentence. We want to be able to solve and graph. We want to use an inequality to solve word problems. We want to look at some problems where we have to determine whether an inequality is sometimes, always, or never true. And we want to look at compound inequalities where we can solve and or inequalities. Alright, so let's jump in. Alright, so first thing, we want to be able to write an inequality as a word sentence. And we want to graph it. So the inequality we first see is x is greater than 4. So we would write x is greater than, that's an E, greater than 4. Alright, so over on my graph, 4 is going to be on the middle of my number line, and we know that numbers greater go to the right and numbers less than go to the left. So we increase, so we'll go 5, 6, and we decrease, so 3, 2. Alright, since it's greater than 4 and it's not equal to 4, we are going to have an open circle on our number line to show that it's not equal to 4. These are just numbers that are greater than 4. And the numbers that are greater than 4 are 5 and 6. So we want to shade in this part of our number line, indicating that these are the numbers that are greater than 4. And we're going to put an arrow also. Alright, so notice on my number line or on my graph that I shaded right on the graph. I didn't shade above it. I made it a little bit darker so I could tell where the shading was happening. And since it's greater than and not equal to, I used an open circle. Alright, so the next one, x is greater than or equal to 4. Let's write that out. X is greater than or equal to 4. So x is a variable, so we don't know what it is. We just know that it could be equal to 4 or it could be greater than it. So back to our number line, we're going to use those same numbers. 4 goes in the middle, 5 and 6 is greater than it, 3 and 2 are less. This time, x is greater than or equal to. So now, since it's equal to, I can have a closed circle on 4. And greater than, again, I'm going to go towards the numbers that are more than 4. So 5 and 6 with my arrow. The next inequality is x is less than 4. So x is less than 4. So you should notice that the ones that are not equal to don't have a little bar underneath. I think of that bar underneath as half of an equal sign, so that reminds me that it's also equal to. Little way to help me figure that out. Okay, so going back to graphing, sorry. We are going to have 4 in the middle. Oh, I want to use my other color. We're going to have 4 in the middle. 5 and 6, again, they're greater than it. And then 3 and 2 are less. This time it's less than 4, so it's not equal to it. So I have an open circle. And the numbers that are less than 4 are 3 and 2. So I'm going to shade to the left this time and put an arrow here. Alright, the last inequality statement in this chart is x is less than or equal to 4. So let's write that out. X is less than or equal to 4. Alright, so again, 4 is in the middle, 5 and 6 are greater than it, 3 and 2 are less than it. I'm going to have a closed circle on 4 because it's greater than or equal to. The equal to part is why it's closed. I'm sorry, it's less than or equal to. And 3 and 2 are less than 4. So I'm going to shade in this direction. I'm going to put an arrow over this way. Alright, so here's a few examples of our graphs. Now let's write an inequality from a sentence. So in our example below, it says 5 fewer than a number is at least 12. So keywords here, at least. We have to decide which inequality symbol does at least indicate. We know fewer than means minus, 5 fewer than, and we have this keyword than also, which tells us to flip it around. So 5 is actually going to go after the minus sign. So it'll be like minus 5. And 5 fewer than a number, so the number goes on the left side, is at least 12. So we know it could be 12, and it should be more than 12. It's at least 12 or more. So if you say, like, I have at least $5, well, that means you have 5 or more dollars. So more would be greater than, and at least we could have 12, so it could be equal to 12. So here we go. X minus 5 is greater than or equal to 12. 5 fewer than a number is at least 12. This would be the inequality that we could come up with from that sentence. Alright, so now it's your turn. I want you to write an inequality from the quotient of a number and 3 is no more than 15. So the key words to decide on what inequality symbol to use is no more than. Sorry, there we go, no more than. Alright, so take a second to figure that one out and join me on the next slide. Alright, so now let's solve and graph an inequality. So step 1, solve the inequality as if it is an equation. I'm going to use the same steps. Note when multiplying or dividing by a negative number, so if you decide that you need to multiply both sides by a negative or divide both sides by a negative, you must flip the inequality. So it's a big deal. Make sure you do that. Alright, so after we solve, step 2, we'll graph by placing a circle. Might be closed or open. I guess we could say a point. Well, I like circle. At the value found, and don't forget you need to shade left or right. Okay, so let's solve. Step 1. Here's our example. So the first thing I would do is I would distribute. Always get rid of those parentheses. So negative 3 times 2x is negative 6x, and negative 3 times negative 5 is positive 15. And we'll carry down the rest. We have a plus 1, we have a greater than or equal to sign, and a 4. Alright, so now I want to combine like terms on my left side, combine like terms on my right side. I have a positive 15, a positive 1, so I have negative 6x plus 16 is greater than or equal to 4. Now I don't have any other like terms to combine, so I want to start to isolate my variable. So I'll first undo the addition, so I'm going to subtract 16 on both sides of my inequality. So I have negative 6x is greater than or equal to negative 12. And then to solve for x, I need to undo the multiplication by division. So I'm going to divide both sides by a negative 6. And note, when multiplying or dividing by a negative, flip the inequality. Alright, so these negative 6's cancel. I have x. I need to flip this inequality so it's less than or equal to. And a negative divided by a negative is a positive, and 12 divided by 6 is 2. So I have solved my inequality. Here's my answer. X is less than or equal to 2. I want to graph that now, so here's a number line. I'm going to put 2 right in the middle. I need a couple numbers after 2, so 3 and 4. A couple numbers before 2, so 1 and 0. I'm going to graph it by placing a circle at the value found. My circle's at 2. And I'm going to shade left to right. Well, x is less than or equal to 2. So since it's equal to it, I need to shade this in, first of all. And then since it's less than 2, well, I know 1 and 0 are less than 2. So I'm going to shade to my left. Alright, so now you go ahead and you try your problem go ahead and solve it and graph. Alright, so now let's look at the last ones we're going to look at in this video. We're going to save the next couple slides about compound inequalities for class tomorrow. So here we want to decide if we have no solution, or one solution, or maybe multiple solutions. And depending on that, we can decide if our inequality is sometimes true, always true, or never true. So, as you can see above, it will be never true if we don't have a solution. It will be always true if we have a true equation, and it will be sometimes true if we're left with a variable in our problem. So let's look at this. In this example, we want to solve. So to solve, I'm going to distribute this -2. And I get negative 6x minus 2 is greater than negative 6x plus 7. Alright, well, now I want to bring my variables together. So I'm going to add 6x to both sides of my inequality to combine those. And when I do that, you should see that they cancel each other out. So really what I have left is this -2 is greater than 7 because the x's got canceled out. I don't have any variables left over at all. All I'm left with is this statement. The statement that says -2 is greater than 7. Is that a true statement? So is -2 greater than 7? And the answer to that question is no. No, that is not true. Therefore, this inequality is never true. Because that's not a true statement. -2 is not greater than 7, ever. So no, this is never true. Let's look at this other example. In this other example, we want to start off the same way. We want to distribute. So we get 12x minus 6 is greater than or equal to 3x plus 12. We want to combine like terms, so I will subtract 3x on each side to get my variables together. Once I do that, I get 9x minus 6 is greater than or equal to 12, because those cancel out. I want to bring more like terms together, so I'm going to add 6 to each side of my inequality, and I get 9x is greater than or equal to 18. And to solve for x, I'm going to divide by 9 since they're multiplying together. So these 9's cancel, and my answer here is x is greater than or equal to 2. Now I'm left with a variable here. X is greater than or equal to 2. Well, this could be true. This is a solution here. It's one solution. So this is sometimes true, is our answer. Notice up above it says one solution, sometimes true. So one solution means you have a variable left, and that's your solution. That's your one solution. X is greater than or equal to 2. Well, this is sometimes true. And it's sometimes true because, well, maybe we'll get a number for x, and the number we plug in, say we get the number 1, x is really 1, well 1's not greater than or equal to 2. So that's why it's just sometimes true. Alright, so this is your last problem over here, your you try problem. Go ahead and knock it out. Like I said, we'll finish these notes tomorrow in class. So see ya.